Hey everyone, as promised, this is a follow-up session on last time's session on converting callbacks into suspending function. So just a quick recap. This is a map screen, and we have some logic that allows us to request for location permissions and also show a location rationale if a user decides to decline accepting location or rather declining granting location permissions. So we have our main action, which basically allows us to dispatch the user actions when the user interacts with the application. So in this instance, when the user decides to either grant or decline location permissions, then we have our main state, which helps us keep track of those location permissions, and then the view model to handle those user interactions, and of course manifest, which allows us to declare the permissions that we're going to be using in our application. So let's begin. So this function basically, like last time, it allows us to request for location permissions, and I've extended a context from a context object. And for those of us who don't understand what a context is, it basically acts as a bridge between our application and the rest of the Android operating system. So we can use this to basically access system services. In this instance, the system service that we're going to be using is going to be the location service. So we're going to be converting this into a suspending function. So let's start by making it a suspend function. And then, since the location service is a callback, we're going to be using suspend coroutine. And this allows us to basically convert the location callback into a suspending function. So for those of us who don't know what a suspending function is, it's basically a function that suspends the coroutine in which it's called from. So so you can think of this as a function that if there's a blocking call, it will suspend the coroutine in which it's launched from until it gets whatever results it's going to be getting, and then that coroutine will resume its execution. So when we use the suspend coroutine, this now gives us access to control, or rather, it gives us control access to the coroutine so that we can be able to decide whether we're going to resume the coroutine after being suspended. So in this instance, we are going to be waiting for some form of result. That will be the location. And then as soon as we get the location, we're going to resume execution of the coroutine. So, like I said, it gives us access to a continuation object, and the continuation object keeps track of the current state of the coroutine in which this get location function is invoked from. So, we're going to need access to a location manager, and we can get that from using the get system service function. And then we'll just pass in. It expects this is an extension function, a Kotlin extension function, which allows us to basically specify the type of system service that we want, and we're going to use an null assertion to cast that as not nullable, because we expect every device that is going to be using this app to be using a to be having location services, because every Android device nowadays has that. And we're going to need to first of all check whether whether a user has location permissions. So we're going to be using what we've defined here. So find location and course location. So I'm going to create the first variable, which is as find location permission, something like that. And then to check for that, we can use context compact dot check self permission, which takes in a context and the permission that we want to check for. And then we're going to compare that with package manager dot permission granted, like that. Let me copy this and then has course location permission access course location. So those are the two permissions that we'll be checking for. And then I'll open I'll use an if check. So we'll check whether a user has granted find location and course location permission. So has course location permission. So if those two permissions have been granted, then we're going to begin location tracking. So we're going to call get current location. We'll use the first overload. And then for the provider, we can simply use the location provider, and we can get that from since it's a static value using LocationManager.network provider. And then it expects a cancellation signal. So we're going to pass null. And then for the executor, we'll simply use main executor since it's a callback and it's thread safe. And then for the consumer, we can use an anonymous object, anonymous class, and then which expects a consumer of type location, like that. And then we'll simply override accept, like that. And if we decide to, let's jump into this consumer interface. We can see that it's a functional interface, meaning it only has one one method. So that means we can take advantage of Kotlin's conciseness and get rid of this block, and then we can use a trailing lambda, and then that gives us access to a location, like that. So now that we have access to the location, we can basically resume the coroutine with the location. So there's a handy resume function that we can use. Then we're going to resume that coroutine with that location. Else, if we don't have, if the user has not granted any location permissions, then we can decide to resume the coroutine with an exception. Then we can use a runtime exception. And then maybe we can say something like user has not granted location permissions, like that. And that should do it for us. So let me connect my device and see if that will work. Moment. I think we are not yet connected. We should be connected in a moment. Right. No, that is not working. Okay. So let me run the application on my device. Then we'll see what we'll have as a result. So if I close that, we can see that we have the location coordinates, so the latitude and the longitude. That was already predefined in the main activity. So if I step into that function, or rather step in out of that function, you can see that we are using the context.getLocation, like that. So that works. But this does not support coroutine cancellation, meaning if this function is if the parent coroutine is cancelled, then we're still going to be getting location updates. So assuming this is suspended for 5 seconds and the calling coroutine is cancelled within a second, then that means we're still going to get the location update. That's not what we want because that's not ideal. So we're going to be using suspend cancelable coroutine, and what this gives us access to is continuation dot invoke on cancellation. So as soon as our parent coroutine or our calling coroutine is cancelled, this block will be called. And if we look at the get parent location method, we have access to a cancellation signal. So this cancellation signal allows us to basically tell this function, or rather the location service, that we no longer want uh, to get location updates. So we can define a cancellation signal up here. It's just a simple class, and then we can pass that over there. Then as soon as the parent coroutine cancels, this suspending function, we can call cancellation signal dot cancel, and that's how we support coroutine cancellation inside this block. If I run the application again, it's still going to basically do the same, but with the added advantage of supporting coroutine cancellation, and that is good. So a quick recap on what a suspending function is. A suspending function basically is a function that suspends a coroutine that calls that function. It suspends that coroutine at the point of cancellation, at the point of invocation. That is, and use the suspend cancelable coroutine or a suspend coroutine to get access to a continuation object, and that gives us the freedom of deciding what we want to do with the state of the coroutine. In this case, as soon as we get the result, we can decide to resume the coroutine. If we don't have access to the location permissions, we can resume with an exception. And we used suspend cancelable coroutine so that we can be able to keep track of whether the coroutine that is calling this suspend function has been cancelled. As soon as it's cancelled, we call cancellation signal to cancel, and the cancellation signal is what we pass to the callback, and that allows us to basically stop location tracking. And that's basically it. So see you guys on the next one.